Hey, so let's hit up 6.5. 6.5 is pretty quick. We are using a lot of the properties that are on those notes. So 6.5, the first half of your assignment is all about expanding and contracting logarithms. So we have these properties in our notes that are log A of m n, and we have this property log A of m over n, and then a final property that is log A of m to the r. So these properties help us to expand and condense. Let me get the r on there. And then we'll talk about how to expand this out and to condense things down. So whenever you have two items that are being multiplied inside a log parenthesis, that becomes addition. Okay? So basically, you just separate them out. Log A of m plus log A of n. So multiplication separates into addition, and vice versa. If I have two logs that have the same base that are being added, they come back together and become multiplication. Okay? Well, if multiplication becomes addition, then division becomes subtraction. So log A of m minus log A of n. So again, it works both forwards and backwards. If you have division going on, you can separate them out and expand out with subtraction. If you have subtraction going on, we can condense it back down into division. If you have log A of m to a power, so we got some piece in here to a power, then we can take that power and we can shift it in front. So we just take the power from the top and we move it right in front. So these three ideas are what we're going to be using to expand this out. Or, as you'll see soon, to condense it down. Okay? So, right here, what's going on in here? Well, we have two items being multiplied. We've got 25 and x. Well, multiplication is really the same thing as expanding out to addition. All right, so we've got log base 5 of 25 plus log base 5 of x. See how that expanded out? It's now longer from left to right. Again, these are those properties. Okay, now the last thing you have to do, if any of these we can figure out, we do want to figure them out. So like this log base 5 of 25, again, I've shown you in your calculator, go to math, scroll up, select this guy right there, and put in the 5, and then put in the 25, and that guy has to become the number 2. So any logs that we can simplify down, we do need to simplify them down. So in the end, this is the expanded answer that they're looking for. 2 plus log 5 of x. And there we go. All right. So go ahead, pause the video, give this one a shot. All right. So first things first, whenever you deal with expanding out, you always take care of all the multiplication and division first. And then the last thing you deal with is the, powers. So here you can see that we have division going on. So what does division become? Division becomes subtraction. So we've got log base 2 of x to the third minus log base 2 of x minus 3. So we took care of the division. Now, do I have any powers in here? Absolutely. This 3 right there. So it needs to go in front. So we got 3 log base 2 of x minus log base 2 of x minus 3. Do not distribute the log base 2 through that. It doesn't work like that. Okay? And this is actually the final answer because there's no reducing here. I can't reduce log 2 of x because I don't know what x is. So, and I can't do any reducing over here. So this is the fully expanded out answer. Okay? So half of your assignment is taking a condensed down piece of a log and expanding it out with addition and subtraction. Okay? The other half is taking something like this and condense it back together. Okay? So just reverse those steps that we talked about. So when we were expanding out, we took care of the multiplication and division first, and then we took care of the powers. In order to condense it back down, move the powers back, and then take care of all multiplication or then take care of all addition and subtraction, which becomes multiplication division. Okay? So go ahead, pause the video, give this one a shot. Okay, so do I have any powers? Absolutely. Any number that's in front of a log is a power. So these powers need to go back where they belong. So the first thing is we get log base 5 of u to the third plus log base 5 of v to the fourth. Now we've taken care of the exponents. Now we just take care of any addition or subtraction. Okay, what do we got going on? We have addition. So what is addition? It's multiplication. So we put it together with log base 5 of u to the third, v to the fourth in parentheses, because that's multiplication between those two. And this is what they're looking for. That's what they want. That's condensing down. You're just reversing what we talked about over here. So when you expand out again, take care of multiplication and division by turning it into addition and subtraction, and then take care of any powers and move them out front. To condense down, take care of the powers, put them back as powers, and then take care of addition and subtraction and turn it back into multiplication and division. That's half of your assignment right there. Now the next one, well, again, it wants you to evaluate. You already know how you can go into your calculator and plug this in. Log, or go into math. Choose this, math. Choose A, and just put in what you know. It's 3, and then 21. Make sure, yeah. And then all you got to do in your calculator is hit enter. And it says round to the nearest thousandth. Okay? So, thousandth, well, this is tenth, hundredth, thousandth. So what does this 2 say to the 1? Stay the way you are. So this answer is 2.771. But there's another way to do this. Whenever your log base is not a 10, as in log base 10, or the regular log, as we would call it, or as long as it's not ln, okay, because we have our calculators that can help us with those, which you already know that ln is the same as log base e. Let me actually write that. And we talked about this in previous ones. Okay? As long as it's not any of those, because we have our calculators that can help us figure out those answers, we have what is called a change of base formula. So this is for any time that our base is a value. I can't spell. Change of base. And again, this is on those property sheets that I gave you. So anytime our base is not 10 or e, we run what is called a change of base. Okay? So anytime our log base is 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, so on and so forth. Okay, the change of base formula looks like this. We've got log base A of m. So to change the base, in other words, to evaluate this, and this is what we had to do before we had that fancy way of using our calculator, and where our calculator can do any base. And actually, whenever your calculator runs this, just so you know, it is doing the change of base formula behind the scenes. But before we had our calculators that can do this, this is how I used to have to evaluate logs. The change of base formula says that you're going to take log b of m over log b of a. So this log b could be any other base that we wanted to convert to. So like log base 3, okay, or 4 or 5. But again, because our calculators couldn't do other logs, our calculators can only handle these. This is why we have these other two ways of figuring it out. So another way of figuring out a change of base is that you do log base 10 of m over log base a. Because our calculators do have the basic log right here of log base 10. Or our calculators also have ln. So you could run ln of m all over ln of a. This is what we call the change of base formula. And before we had calculators that can handle this, this is how we used to have to evaluate. So if I'm looking at this equation or this piece that I have up here, this expression, if I was going to run these formulas, they would look like this. Log 21, because 21 is our m, all over log 3, because that's our base, which is a. Or I would get the same answer if I ran ln of 21 all over ln of 3. Just to show you. Again, this is what I said. Whenever your calculator runs these, they're doing a change of base in the background. So if I hit alpha y equals, here is my log base 10, log 21, close it, put it all over log of 3. And again, this is our log base 10. This is the change of base formula I wrote a second ago. See? Same answer. Or if I did alpha y equals ln of 21 over ln of 3. Same answer. Okay? So if your directions say run a change of base, well, you can run this formula, or again, we could actually just put this in our calculator because our calculator runs that change of base formula when we put this in. This is us telling our calculator, do change of base. Okay? It all gives you the same answer. And these are the ways that we used to have to evaluate logs before our calculators could do this. We had to do that change of base formula. Okay? All right. And last but not least, again, we go back to simplifying. And again, remember that we had properties that we've talked about in previous videos, that whenever you have a base raised to a power of a log with the same base, remember that whenever you have exponentials, and this is an exponent with a log of the same base, whenever the exponent base and the log base match, what happens to those? They cancel out, leaving you with x. And the same thing, if I had a log base a and it has an a to an x, so I've got a log with an exponent, and both of these exponents have the same base, just like what happened here, The log and the base of the exponent cancel out, leaving you with x. Go ahead and pause the video and give these two problems a shot thinking about what we just talked about. And go. Okay, so if you look at this first problem, notice I've got a base of 2. Notice it's raised to a power of a log with the same base. That's what we're talking about right here. So if I take 2 to the log base 2, all that's going to happen, I get 6. And again, you can go to your calculator and actually, plug this in and see that that's what happens. So you got 2 raised to the power. Go into your math to select that log where we can do any base we want. Put log base 2 and put a 6 inside the parenthesis. That's what we had. We want to simplify, or in other words, evaluate. See, 6. That's because these two are canceling each other out because they're the yin and the yang to each other. Exponents are the inverse to logs, and logs are the inverse to exponents. They cancel each other out. They undo each other. Like squaring takes care of square roots. Square roots take care of squaring. Adding has subtracting. Subtracting has adding. They're inverses to each other. All right. And then over here, remember that ln is log base e. So I've got a log base e with an exponent that has the same base e. What's going to happen? The ln and the e cancel out. And what are we left with? 16. And again, I can go into the calculator and put that information in the way I see it, and it's going to kick out that same answer. ln, second ln to bring up the e, put in the 16, scroll out front, 16. Because these two pieces are canceling each other out. And that is 6.5. Enjoy.